Station, this is Houston. Are you ready for the event?
Houston, station's ready for the event.
Google Plus moderator, this is Mission Control Houston. Please call station for a voice check.
Station, this is the Google Plus Hangout. How do you hear me?
Google Plus Hangout, International Space Station. We have you loud and clear aboard. We have our own way of hanging out up here. Watch my buddies hang out. We're ready to hang out with you guys. Welcome aboard.
Awesome. We have a lot of questions for you guys today, so let's start with our first one from YouTube.
I'm Kristen Lau.
I'm Maria Ravi.
And we're from Union High School in Iowa. Our question is,
what is the exact purpose of having humans live on the space station?
Thanks.
Over.
Well, the whole point of having a space station is to have some place in space where people can take their ideas. We have a huge power supply up here. We have a lot of rack space, and we have a lot of scientists on the ground with a lot of ideas about things to do in space. We have literally hundreds of experiments going on right now as we're working up here. And the space station really offers a lot of flexibility to us that you wouldn't have. If you wanted to put an experiment in space and you didn't have a space station, I don't know where you'd put it. Right next to us is a rack. Yesterday we took an experiment out of it called In Space, which is looking at special magnetic fluids that can change the way we have really changed the operation of braking systems, and maybe have applications to seismic dampers and stuff for earthquake zones. Many good offsets from that particular experiment. And we finished it out yesterday, and we're going to put in a new experiment next week that's coming up on Dragon. And it'll look at a completely different kind of thing. It'll look at the way metals form in zero gravity, and it's very important for us to look at the way the crystals form because it can make things very much stronger. And so these are things that can only be done in zero gravity, and we have no lack of ideas of things to do up here, and we're here to facilitate it.
Thanks. We're going to take our next question from YouTube. It's Simon Drubel, who asks, do you sometimes see falling stars in the atmosphere from the space station, or is it frequent, or do you see stuff like satellites in orbit? Thank you, from Belgium.
As a matter of fact, shooting stars we do see, but there's one big difference. They're below us instead of above us. So when we're looking down at the Earth, we can see a little shooting star. Usually you don't see much movement other than the Earth slowly going by you. And so when it really catches your eye when you see a shooting star, a lot of movement there in the atmosphere. It's very beautiful. We don't see other satellites typically because we're all going very fast, 17,500 miles an hour. And if one's in an orbit near ours, in a slightly different orbital plane, we pass by each other very quickly. I've heard some astronauts have seen some go by, but it's a very rare event. Great question.
All right. Thank you. Why don't we take the next question on YouTube?
I'm Destin from Huntsville, Alabama. This is Sadie and Spotsy. On the International Space Station, if you're free-falling in one position without touching anything with no spin, is it possible to wiggle in such a way that you're able to rotate to a different angular position and then stop? On Smarter Every Day, we demonstrated this with a high-speed camera and a cat who is a non-holonomic system and can do this by extending his legs, arching his back, and twisting in a very specific pattern. So can humans do this on orbit? You want to say hey to the astronauts?
Hey.
Thank you. We look up to you guys.
Okay, well, that's a great question. We don't have any cats on board, but we have a medical doctor who maybe can try to demonstrate the next best thing to a cat. So he's going to try to demonstrate for you. Yes, indeed, you can do this. So he's going to get out here and stop himself in open space, and he's going to show you how he can turn himself around. So he can't change his angular momentum, but he can change his body position and move himself to an orientation. So I hope you believe that what you saw happen with the cat isn't a mystery and that it can happen in space too. Great question.
Thanks. Here's a kind of timely question from Facebook. Ian Becken asks, what was the first emotional reaction of the crew when they realized a few days ago that the S-band comm was lost and they weren't able to talk to the ground anymore just over Russian ground sites? Are there any procedures to keep calm in those situations, or does training experience kick into action?
We trained individually as astronauts for many, many years, and we've trained together as a crew for several years as well. So really, we're ready for all sorts of things to happen. What happened just a couple of days ago was really not that big a deal. We lost communications with the ground, but the space station is a robust, tough spaceship, and it kept just going around the world and all of its systems running just fine. We worked together as a crew, following the procedures like we trained to do. It was actually pretty nice. I was sitting there typing on the main interface. Tom was running the procedures with me, and Kevin, as the commander, was staying back, watching how the whole thing was flowing and making sure that we were headed down the right path. The people on the ground were scrambling and working hard, and it wasn't until we came around the world and up and over top of Russia, where we can talk directly from an antenna on the ground to our antennas on board, that then we could compare notes, see where we were, and eventually we got everything together. And after just a couple orbits, we got the computers talking to the antennas properly, so we could talk to the ground. So it wasn't any sort of panic or anything. It was just us dealing with a problem on the ground and our crew dealing with a problem on board, working like we've been trained, working together as a team with a successful result. It was things that happen in space.
Thank you. Why don't we take our next question on YouTube?
Hi, my name's Neil Bramson. I'm a teacher at New South Wales, Australia. My students have been following the Expedition 34 crew progress on Twitter, Facebook and Google Plus now. And my question relates to social media. How do you feel as astronauts now that your communication methods have changed through the use of the likes of Twitter and Facebook, and the impact that you now have on the global public in terms of space and space education? Secondly, how do you feel as social media stars? Thanks very much.
I don't think anybody tries to use technology to push back the edge of the human experience more than we do. I mean, look where we live and what we're doing, how we're making this happen. And so we constantly try and take something simple, but then apply it in a new way and allow it to improve our understanding really as a species. And we are, for the first time in history, with this space station, as a planet, as a species, we're leaving Earth. And it is just, it's too good an experience not to share. And with technology that we have now, with the communications capability that NASA and others have put on board here, we can real time communicate as people with pretty much everybody on Earth who has a computer or an iPhone or something. And so with Twitter, which is a really handy way to do that, we can take a picture or have a thought here on board and just in a matter of a few minutes, get it down to the ground and spread around the world. That's wonderful for viewing things like the big tropical cyclone that's off Madagascar right now. It's a great way to communicate the transient emotions and the thoughts that go through us as we are experiencing this really on behalf of everybody. And as far as being a media star, I mean, this is just a really rare human experience. And we've worked hard to get here, but at the same time, we know just how lucky we are to be here. And I think it's important to try and share it with as many people as possible. But something else to remember, everybody around the world, if you just choose the right time of day, you can look up and watch this star go over as well. And that's a pretty nice touch back and forth also.
Thanks. I'll take another one from social media. I'm not sure if you guys have thought about this or not, but it's something I don't think I've heard asked before. It's on Twitter, @Nozelbar asks, which scientists of the past would you like to take into space, like Galileo, Kepler, et cetera?
Well, for me, it just popped right into my head, Isaac Newton, because we see what he could only imagine. We see it every day in everything we do. Large objects that we can move with a push of a finger, although it takes a little bit of time to get them going. Small objects that bounce around very quickly. The angular momentum demonstration you just saw. All of these things, it's really hard to believe that he was able to imagine these things. And I would love for him to be able to see it.
Great. Why don't we take another question on YouTube?
Hi, my name is Jennifer Gates, and I'm a high school science teacher in the Midwest of the United States, mostly teaching chemistry and physics. And my question for you is, what's the most important thing that they should be learning and focusing on understanding at this time in terms of perhaps working in science later? Or what do you feel like the most important thing was that you took from your high school science courses to help you get where you are today? Thank you.
Well, that's a great question. I wish I could have taken everything in high school twice, actually, because there's so much information there for students at that time, and I know that's a really tough time in their lives and everything. And it is almost overwhelming, all the subjects that are offered to you and the choices that are offered to you at that time. I loved math and I love physics, and I happened to have a very enthusiastic physics teacher who just made me, I just couldn't wait to go to class every day. And we talked about things like, Newton's laws and that sort of thing. And like Tom just mentioned, we get to see him up here in action, and in their advanced phases and stages as well, like in orbital mechanics and those sorts of things. So that's the one that really piqued my interest. But we have a life support system on board that's very chemistry intensive, and we talk chemistry almost every day. We use mathematics every day. It's very important in mission control, too, for the people who support us. Trajectories to get up. I'm going back to Earth in about 3 weeks, and there are some brilliant mathematicians working on putting me in a very small spot in Kazakhstan. So there are people working, waiting there for me, and they're doing calculus, and they're running it backwards so that they can integrate all the way back to the ground and get me to the right place on the ground. So it's a lot of complicated science to make this all work. There's medical, you can see Chris has got a special thing on his head today. The medical science is very important to us and what we're doing on Space Station. And no matter what you like, what your field is, you can find an area in that applies to space flight for sure. So just take all of them that you can and learn as much as you can about all of them. You'll probably need them all if you're going to end up in the space business, and you might need them all in almost any business you end up in. So take advantage of it.
Why don't we take another question on YouTube?
My name is Fraser Kane, and I live on Vancouver Island, Canada. And my question is for Chris Hadfield, who's been delivering all these beautiful photographs from space. And my question is, how does being on the International Space Station change your photography technique with the microgravity, the very harsh exposures, the very distant objects that you're trying to focus on, and perhaps the low light conditions? Thank you very much.
Hey, thanks, Fraser. And I used to live on Vancouver Island as well. It's a beautiful part of the world and nice part of Canada. Taking pictures up here, especially outside, is quite complex at first. Fortunately, we have really good instructors down on Earth, some really good trainers who taught us, prepared us, gave us a lot of good tricks. The weird part about it is space is so incredibly black, so incredibly dark. It's a bottomless pit of deep black, almost so deep it almost has a texture when you look at it. And when you have that in part of your picture, and then the world reflecting the sunlight, especially the tops of clouds somewhere else, it's very difficult, at least for people who aren't professional photographers, to try and balance that and get a picture that looks good both ways. And the advantage of being in space, though, of course, we have cameras with fairly typical lenses on them, but we can get right out to 400 or 800 millimeter lenses, and they're weightless. We don't need a tripod. So every photographer in the world would love to have that much glass out in front of their eyes and not have to hold it up or not have to balance it. The best part is, even though we're not photographers by trade, of course, we have some really good professional photographers who train us, and we have a vantage point up here, a perspective that is absolutely unparalleled. So we do our best to take pictures of it.
Thanks. Yeah, I'm not sure there's a bad shot of Earth from Space Station. The next question from social media is on Google+. It's from Hippiness Wins. And the question is, astronaut Marshburn, Ford, Hadfield, good morning. And what is that on Chris Hadfield's forehead?
Well, what he has on his forehead is actually a temperature probe. So it's two things being investigated here. Number one is the technology. It's really nice to be able to measure body core temperature without having to get too invasive. And so what that's doing is he's got another one on his chest and is measuring his core temperature. And the reason why they're doing that is your body temperature, the core temperature, is a good indicator of how your body cycle is moving, your circadian rhythm. We don't have sunrises and sunsets coming through the window like you do on Earth. We have 16 a day, actually, so it can really mess up your circadian rhythm. So they're learning a lot about how our body functions through this kind of time cycle that's very strange. And it has a lot of implications for people that do night shifts and that work extremely long hours, and for astronauts living in space, how we can improve work efficiency and improve rest as well.
Great. Let's take another question from YouTube.
My name is Mira Richmond. I live in Bolivar, Missouri. I am in 2nd grade and I am 8. The other night at dusk, I saw you guys fly over my house. How long do you guys stay up there in the space station? Who has the record for staying up there the longest? Thank you.
That was a good one.
Yep. Well, I'm glad you could see us. Hopefully one of us was waving back at you. We can stay up here about 6 months, and that's actually a limitation of our spaceship that gets us here and brings us back home again. It's certified to be up here in space for about 6 months. Humans can stay up longer. The longest is Dr. Polyakov. He's a cosmonaut, and he lived on the Mir space station for 14 months, actually. So, and we're going to have a few astronauts and a cosmonaut living up here for up to a year here in the next couple of years or so. So right now, as far as we can tell, there's no limit how long humans can stay up here, as long as we have the machines here to keep our bones and our muscles strong and have enough food and water and such, and a lot of great work to do, such as we're doing here right now. And of course, the view of the Earth helps us stay up here a lot as well.
Great. We'll take another question from social media. This is from Facebook. Sheila Averbush asks, what was the most influential book you read that helped inspire you to go to space?
Well, I actually was inspired to pursue becoming an astronaut because of a book I read when I was about 13 or 14 years old by an astronaut named Michael Collins, who was part of the Apollo 11 crew.
Me too.
And it was called Carrying the Fire. And it was a fantastic account of his early life as a pilot and test pilot. And I just really fell in love with that profession because of that book. And of course, what he did was one of the most magical things that's happened in the course of human history, as far as I'm concerned, with the trip he took to the moon with Neil Armstrong and Buzz Aldrin. So that's what inspired me, that particular book. After that, I read lots and lots more that just inspired me further, but that was really the one that set it all off.
Great answer. Why don't we take another question from YouTube? We have a couple more minutes before this portion of the event concludes.
Hello, astronauts of the International Space Station. My name is Carolina Morales, and I'm a student of the Neil Armstrong Institute in Monterrey, Mexico. On behalf of my classmates, we would like to ask you the following question. How are you prepared to face medical emergencies in the space station? How do you treat regular sickness, and what do you do in case you need surgical attention? Thank you very much.
So we can actually handle some pretty big emergencies up here, medical emergencies. First of all, we always have 2 crew medical officers on board. They could have any background, but they're trained to apply first aid or take care of emergencies that can keep somebody alive for up to 24 hours. I happen to be a doctor, but there's no requirement to have a doctor up here all the time. But right under our feet here are some medical kits, and they are packed full of everything you need, from, say, an aspirin to an IV if you got really sick. The big answer, though, is if we ran into a big problem, and that's a defibrillator. We hope we never have to actually use that, but we know how to use it. That's the emergency kit, the big red kit. The big answer, though, is our Soyuz is our ambulance, and we would hop in the Soyuz and bring somebody home if we thought that they were going to be have a real big problem or even die from a medical problem up here. Not to mention all the doctors on the ground who have not only been preparing us for preparing this equipment and the procedures and the techniques, but also would be giving us advice real time if something happened. Space motion sickness is really common. There's about 3 out of 5 astronauts get it. We've got some medicines to take care of that, so it's really not much of an impact anymore.
Thank you. That concludes our portion. We really appreciate you guys from joining us on International Space Station. Please stay with us for more questions from astronauts here on the ground.
Station, this is Houston ACR. Thank you. That concludes the event.
Thank you, Google Plus Hangout participants and NASA social media guests. Station, we are now resuming operational audio communications.